Today we will see chapter 3, section 3.4, the slope of a line. And the first objective is to find the slope of a line given 2 points on the line. The slope is usually represented by the letter M. It's going to be calculated by rise over run. That means here, if you get two different points, let's say this point here and that point over there, this distance here on the x-axis is going to be the run, and this distance here on the y-axis is going to be the rise. Okay? And the slope is rise over run. Let's say this point here is point 1, this is point 2, this is x1, y1, x2, y2. Then rise is y2 minus y1, right? This distance here is going to be coordinate y2 minus coordinate y1. And run is going to be coordinate x2 minus coordinate x1. Therefore, rise M, which is rise over run, is rise y2 minus y1 over run x2 minus x1. And that's the formula that you see here in the PowerPoint. Example: find the slope of the line through coordinates, let's say 0 and 3, this is point 1, and 2 and 5, this is point 2. Let's assume this is point 1, this is point 2. Well, it doesn't matter if you say this one is point 2, that one is point 1. The calculation here is, you're going to use this formula. y2, if we say this is point 2, y2 is 5, y1 is 3, x2 is 2, x1 is 0. 2 over 2, 1. So slope equals 1. And this example. Another example. Find the slope of the line containing the points. So one of the points is 4 and negative 3, and the other point 2 and 2. Let's say this is point 1, this is point 2. Formula equals y2 minus y1 over x2 minus x1. All right, y2 is 2 minus y1, negative 3. x2, 2 minus x1, 4. That means that m equals 2 minus negative 3 is 2 plus 3, right? And 2 plus 3 is 5. 2 minus 4 is negative 2. So negative 2, we can bring the negative sign here, and 2 here on the bottom. 5, negative 5 over 2. One thing that we can say about the sign of the slope, if the sign of the slope is positive, that this example here, m equals positive 1, the slope goes upwards. And if the sign of the slope is negative, this example here, m equals negative 5 over 2, the function, the line points goes downwards. Okay. Hint, helpful hint. When finding slope, it makes no difference which point is identified as x1 and y1, and which one is x2 and y2. It doesn't matter, as I told you. You can say this one is 2, this one is 1, as long as you don't mix up the coordinates. Just remember that whatever y value is first in the numerator, its corresponding x value is also first in the denominator. This. If this one here is y2, then you have to start the denominator with x2. So and basically this will influence the sign, the resulting sign of the slope. Okay, next objective. Objective 2. Finding slope given an equation. When a linear equation in two variables is written in the slope-intercept form, that means y equals mx plus b, m is what? Is the slope, right? And b is going to be the y-intercept. Let's apply this new thing here to an example. Find the slope of the line. Let's skip this. Find the slope of the line. Negative 3x plus 2y equals 11. What you have to do here is change this equation to be on this form here. So keep just y on the left hand side, just the variable y, and everything else goes to the right hand side. Means addition property, plus 3x on both sides. 0 plus 2y equals 11 plus 3x. And now you can divide both sides by 2. Y equals, and let's represent first here the x term plus 11 over 2. Right now it's in the right form, is in the standard form. We can identify the slope. Slope m 3 over 2, and the y-intercept. Y-intercept is going to be 11 over 2 and 0. I mean, the opposites. 0. Y-intercept is where x equals 0. Sorry. 11 over 2. That's it. Another example. Find the slope of the line. Negative y equals 6x minus 7. Now we are almost there in the standard form. Remember, the standard form is y equals mx plus b. But the only thing that's not good is this sign here. So let's multiply everything by -1 or divide everything by -1. Then we have y equals -6x plus 7, right? So now we can identify m, which is -6, and the y-intercept 0 and 7. Okay? Let's go to the next objective, interpreting slope-intercept form. And this example now is a word problem. We have the adult one-day pass price for Disney World is going to be represented by Y. Is given by 3.53 times X plus 67.39, where X is the number of years since 2006. Number of years since 2006. Use this equation to predict the ticket price for 2026. If X is the number of years since 2006, and the year that the question is asking is 2026, how much is the value of X? Basically, 2026 minus 2006 equals 20. Now plug in this, X equals 20, on the equation that you have here. Y equals 3.53 times 20 plus 67.39. And then you're gonna have Y equals 137.99, which is the answer. Okay, now objective 4, finding slopes of horizontal and vertical lines. And this is quite simple. Let's go straight to an example. Find the slope of the line x equals -2. X equals -2. What's the slope of this line? You know that x equals -2. Let's draw quickly here the graph. X and y. If x equals -2, I mean here, -2. So the line is going to be here, vertical line, right? And a vertical line, you're going to have, if you try to calculate, you're going to have y2 minus y1, x2 minus x1. X is going to be always -2. That means you're going to have a fraction with 0 on the denominator, right? And something here. When you have a fraction with 0 on the denominator, this is undefined. That means the slope of a vertical line, a function like this, is undefined. You cannot calculate because the denominator is going to be 0. In this situation, for any 2 points, the x will be the same. The denominator is going to be 0, so the slope is undefined. Now another situation, and let's illustrate with an example. Another example, y equals 3. What about this situation? And let's draw really roughly the graph of this line, x and y. 1, 2, 3. This is y equals 3. So 1, 2, 3. This is the line y equals 3. Okay? What can you see about this line? What can you say? This is a horizontal line, right? And if you try to calculate the slope, you're going to have y2 minus y1 over x2 minus x1 equals, and the value of y is constant. And this situation here is 3 minus 3 over something. And 3 minus 3 is 0. 0 over something is always 0. The slope of this line, y equals 3, is 0. All horizontal lines will have the slope of 0. For any 2 points, the y value will be equal to the same real number. The numerator in the slope formula is equal to 0. And that means that the slope is going to be 0. All horizontal lines have a slope of 0. We've seen before, if you have a positive slope, the line is going up, right? Upwards. The line is growing, is pointing up. Like this. And a negative slope. The m negative, then the line goes downwards. Here y increases, here y decreases. And now objective 5. Compare the slopes of parallel and perpendicular lines. Two lines that never intersect are called parallel lines. The parallel lines have the same slope. M is equal for both lines. I'm gonna have also different y-intercepts. Two lines that intersect at a right angle, they're called perpendicular lines. Two non-vertical perpendicular lines have slopes that are negative reciprocal of each other. The product of their slopes is going to be -1. And let's determine whether the line 6x plus 2y equals 9 is parallel to -3x minus y equals 3. So the first thing, we have to find the slope and compare, right? So for the first equation, let's work in the first equation here. 6x plus 2y equals 9. Let's make it in the standard form y equals mx plus b. Let's get rid of x from this side. Negative 6x plus 9, right? And now we can divide both sides by 2. Y equals negative 6x divided by 2, negative 3x plus 9 divided by 2. This is number 1. Let's check now number 2. Number 2 is this one, right? Number 2. Negative 3x minus y equals 3. Let's get rid of this negative 3x. Adding addition property, add 3x from both sides. Negative y equals 3x plus 3. And you can multiply or divide both sides by negative 1. Y equals negative 3x minus 3. This is equation or line 2. Okay, let's compare now. M1 is negative 3. M2 is negative 3. They are both the same value. That means M1 equals to M2. What can I say about that? Remember, if M1 equals to M2, the lines are parallel. Okay? Next example. Next example, determine whether the lines x plus 3y equals negative 15 and negative 3x plus y equals negative 1. Slope, we need to find a slope, right? For the first one, let's split here. This is going to be the first and the second. And the first is x plus 3y equals to negative 15. And apply here addition property. 3y equals negative x minus 15. Divide both sides by 3. Y equals negative 1/3 x, right? Negative 1 divided by 3 minus negative 15 divided by 3, negative 5. So this is the line or the equation number 1. And number 2, negative 3x plus y equals negative 1. Addition property, add 3x on both sides. So you're going to have now y, 0 plus y equals 3x minus 1. Right? And that's it. What can you see about, are they equal? M1 equals M2. Let's check it out. Oops. Negative 1 over 3, no. 3, they are not equal. Let's try the next one. Let's multiply M1 times M2 equals to negative 1 over 3 times 3. This is equal to negative 1. When you have M1 times M2 equals to negative 1, that means perpendicular. The lines are perpendicular. And one last example. Determine whether the following lines are parallel, perpendicular, or neither. Negative 5x plus y equals negative 6. 5x plus 5y equals 5. So what we're going to find here is slope, right? Let's split on these sides. Let's do the first one. Negative 5x plus y equals negative 6. Add 5x from both sides, on both sides. So now we have y equals 5x minus 6. And that's it. That's it. And this is M1. Now the other side. The other equation, x plus 5y equals 5. Let's subtract x on both sides. 5y equals negative x plus 5. Divide both sides by 5. Y equals negative 1 over 5 x plus 5 divided by 5, 1. Right? And this is M2. We can see they are different, right? So they are not parallel, the lines are not parallel. Now let's try to multiply M1 by M2 equals 5 times negative 1 over 5. That's equals to negative 1. If the multiplication M1 times M2 equals to a negative 1, so if the product is negative 1, the lines are parallel. Let's summarize so we can remember. Perpendicular lines. You're going to have M1 times M2 as negative 1. And parallel lines, you're going to have M1 equals to M2.